Introduction.
Have you ever done calculations with imaginary numbers? Imaginary numbers? What are imaginary numbers? Today our teacher taught us about the imaginary numbers. We can understand imaginary numbers with the help of complex numbers. Oh, and what are complex numbers? A complex number is a number consisting of a real part and an imaginary part. Do you want to know about complex numbers? Yes. Please tell me. Okay, come I'll tell you in detail.
Objectives. At the end of this lesson, you will be able to define complex numbers, explain algebra of complex numbers, explain power of iota, explain square root of negative real numbers, learn identities of complex numbers, write the conjugate and modulus of complex number, understand the polar representation of complex numbers. Complex numbers. A complex number is a combination of a real number and an imaginary number. Real numbers are just numbers like 1, 12.38, minus 0.54, 3 by 4, square root 2. Imaginary numbers are special because when squared, they give a negative result. The unit imaginary number is I, that is iota, which is the square root of minus 1. A plus b iota is a complex number, combination of real number and imaginary number. Examples are 1 plus iota, 39 plus 3 iota, minus 2 plus pi iota, square root 2 plus iota by 2. Algebra of complex numbers. Addition. Addition of two complex numbers a plus b iota and c plus d iota is defined as a plus b iota plus c plus d iota is equal to a plus c plus b plus d iota. This is similar to grouping like terms. Real parts are added to real parts and imaginary parts are added to imaginary parts. Properties of the addition of complex numbers. The sum of two complex numbers is a complex number. This property is called closure law. Complex addition is commutative. For any two complex numbers, z1 and z2, z1 plus z2 is equal to z2 plus z1. Complex addition is associative. For any three complex numbers, z1, z2, z3, z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. Inverse of complex addition. Each element z is equal to x plus iota y of the set of complex numbers has an inverse element. Minus z is equal to minus x minus iota y. Algebra of complex numbers. Difference. The difference of two complex numbers z1 and z2 is z1 minus z2 is equal to z1 plus minus z2. For example, 4 plus 2 iota minus 7 minus iota is equal to 4 plus 2 iota plus minus 7 plus iota is equal to minus 3 plus 3 iota. Similarly, 6 minus iota minus 4 plus 2 iota is equal to 6 minus iota plus minus 4 minus 2 iota is equal to 2 minus 3 iota. Algebra of complex numbers. Multiplication. The multiplication of two complex numbers z1 and z2 is AC minus BD plus AD plus BC iota. Properties for the multiplication of complex numbers. The multiplication of two complex numbers is a complex number. This property is called closure law. Complex multiplication is commutative. For any two complex numbers Z1 and Z2, Z1 into Z2 is equal to Z2 into Z1. Complex multiplication is associative. For any three complex numbers Z1, Z2, Z3, Z1 into Z2 into Z3 is equal to Z1 into Z2 into Z3. Inverse for complex multiplication. Each element Z is equal to x plus iota y of the set of complex numbers has an inverse element 1 by Z or inverse of Z. The distributive law. For any three complex numbers Z1, Z2, Z3, Z1 into Z2 plus Z3 is equal to Z1 into Z2 plus Z1 into Z3. Z1 plus Z2 into Z3 is equal to Z1 into Z3 plus Z2 into Z3. Algebra of complex numbers. Division. Division of two complex numbers Z1 and Z2 is defined as Z1 by Z2, where Z2 is not equal to 0. Or we can write as Z1 by Z2 is equal to Z1 into 1 by Z2. Suppose we want to divide the complex number 4 plus 7 iota by 1 minus 3 iota. That is, we need to find. We won't change the value of this fraction if we multiply both numerator and denominator by the same value. We multiply by the conjugate of the denominator, which is 1 plus 3 iota, and then simplify. 4 plus 7 iota into 1 plus 3 iota divided by 1 minus 3 iota into 1 plus 3 iota is equal to 4 plus 12 iota plus 7 iota plus 21 iota square divided by 1 plus 3 iota minus 3 iota minus 9 iota square. On solving, we get minus 1.7 plus 1.9 iota. Power of I. Let's now learn about the powers of iota. I raised to power 0 is equal to 1. I raised to power 1 is equal to I. I raised to power 2 is equal to minus 1. Iota raised to the power 3 can also be written as iota square into iota. We know iota square is minus 1. We get minus iota. Similarly, iota raised to power 4 is equal to square of iota square minus minus 1 square is equal to 1. Iota raised to power 5 is equal to square of iota square into iota is equal to minus 1 square into iota is equal to iota. Look at the table. We can see that iota raised to power 4m is equal to 1. Iota raised to power 4m plus 1 is equal to iota. Iota raised to power 4m plus 2 is equal to minus 1. Iota raised to power 4m plus 3 is equal to minus iota, where m is equal to 0, 1, 2, 3 and so on. The square roots of a negative real number. The square roots of minus 1 are iota, minus iota. This symbol means iota. Take an equation x square plus 1 is equal to 0. We can see that its solutions are iota and minus iota. In general, for a positive real number a, square root of minus a is equal to square root of a into square root of minus 1 is equal to square root of a into iota. Identities related to complex numbers. Identities of complex numbers are as follows. The modulus and the conjugate of a complex number. A complex number z is a number of the form z is equal to x plus y iota. Its conjugate z bar is a number of the form, that is, z bar is equal to x minus y iota. Modulus of a complex number. The product of a complex number with its complex conjugate is a real positive number, that is, z into z bar is equal to x plus iota y into x minus iota y is equal to x square plus y square, and is often written z into z bar is equal to square of modulus of z is equal to x square plus y square, where modulus of z is square root of x square plus y square. For two complex numbers z1 and z2, modulus of product of z1 and z2 is equal to modulus of z1 into modulus of z2. Modulus of z1 by z2 is equal to modulus of z1 by modulus of z2, provided modulus of z2 not equals to 0. Complex conjugate of product of z1 and z2 is equal to complex conjugate of z1 into complex conjugate of z2. Complex conjugate of z1 plus minus z2 is equal to complex conjugate of z1 plus minus complex conjugate of z2. Complex conjugate of z1 by z2 is equal to complex conjugate of z1 by complex conjugate of z2, provided z2 not equals to 0. Polar representation of a complex number. A complex number can be visually represented as a pair of numbers a, b, forming a vector on this diagram called the Argand diagram, representing the complex plane. RE is the real axis, IM is the imaginary axis, and iota is the imaginary unit, satisfying iota square is equal to -1. In polar representation, a complex number z is represented by two parameters r and theta. Parameter r is the modulus of complex number, and parameter theta is the angle with the positive direction of x-axis. The polar form of a complex number is z is equal to r into cos theta plus iota sin theta. This representation is very useful when we multiply or divide complex numbers. Did you know? Complex numbers are used in many scientific fields, including engineering, electromagnetism, quantum, applied mathematics, and chaos theory. Italian mathematician Girolamo Cardano is the first known to have introduced complex numbers. He called them fictitious during his attempts to find solutions to cubic equations in the 16th century. Summary. Let us summarize what we have learned. A number of the form where a and b are real numbers is called a complex number. A is called real part and b is called the imaginary part of the complex number. Let and then, for any integer k, the conjugate of the complex number denoted by z is given by the polar form of the complex number is where